Welcome to the series. In this series, we will learn about LangChain LCEL, which is LangChain Expression Language. This is the current leading helper library to build complex AI applications. This is a beginner level course designed with hands-on practice examples. And if you stick around, I promise, this series will take you to mastery. That said, let's talk about this video, which is part 1 of the series. In this video, we will learn the following. 1. Setting up interaction with OpenAI models. 2. Anthropic model Claude 3.5 Sonnet. 3. Llama 3.2 via Groq services. And last but not least, Google Gemini Pro 1.5. We will also touch on prompt engineering using system prompts. Now let's get started. Alright, so let's take care of the setup part, which involves installation and loading up the API keys. So if I click here, these are the libraries that we need for our current video. So we're going to bring in LangChain, of course, this is the main library. And then we're going to need the LangChain community. And since we're dealing with 4 different models, we're going to be needing the OpenAI, LangChain Anthropic to handle the Sonnet model, and then LangChain Groq to handle the Llama 3.2 model, and lastly Google Gen AI to handle Google Gemini. And now that I have installed it already, so it is actually showing the current LangChain version, which is 0.3.9, and that's the latest and the greatest. Now that's done, let's take care of the API keys. Alright, so at this point we're loading up all the API keys, importing OS from Python, and then os.environ, declaring the environment variables, then just simply dropping the API key right here like this in a string will set up our environment variable. So in here we are doing the OpenAI, the Anthropic, the Google Gemini, and Groq API key. These last 4 are just to set up the Langsmith tracing. Initially we just set the tracing to true, and then we declare our project name, in this case LangChain LCEL Mastermind Series, and this is the Langsmith endpoint that my Langsmith account provided me with, and this is the API key. Using these we can connect to the backend, which is this guy right here. So everything is set up right now. So let's go up here. So once we run something or invoke something from our project, it will show up right here. Now that we have everything set, let's move to the main event. Alright, so this is how this whole video is set up. First, we will look into the OpenAI models, then Anthropic, then a Llama 3.2 9 billion model via Groq, and then Google Gemini Pro 1.5. Let's get started with the OpenAI one. Initially, we're bringing in the chat OpenAI library from OpenAI, and I'm also importing pprint from Python. You will know very soon why. Now, these are the models we're going to be playing with that are coming from OpenAI. One is GPT-4o, O1 Mini, O1 Preview. And in both cases, we're going to be building this LLM object using chat OpenAI. And then we're going to send the same question as a prompt to invoke it. Now, one thing I have to mention is that this LLM in LangChain lingo is called a runnable sequence. And this runnable sequence can be run in 2 ways. One, .invoke. The other one would be with the .stream. We'll handle it later. So right now, we're going to go with the invoke one. And the characteristics of this invoke method is that it will drop the whole answer at once as soon as it is done. But the stream will stream the results, which we'll get to soon. So right now, let's use GPT-4o and this question, who is Sam Altman, in 1 sentence, and use print to see the response. Let's run it. And I will let you be the judge as to how fast this is going, right? Compared to model to model. And now that the answer is here, let's go back to our Langsmith. There you go, it's right here. So let's go in and click on here. And right there, we see all the details, how many tokens used, success or failure, what time, the question, answer, everything, right? And we'll be doing a lot of back and forth with this later on. So now that we know it's working, let's go back. Okay, and as you can see, this answer came in one long result, right? And it comes with an object called content, right? So we can just do a dot content and then run it again. And now we get the actual answer. But then again, still it is just too long for this to hold. And that's when we disable this guy and enable pprint and run again. And now we get to see the full answer. Now we know why we imported pprint, right? Okay, so this is the invoke method. So now let's see how Stream handles it. So we're going to have the same thing here, chat OpenAI, pprint, everything, and we're going to be using the same model, but in this case we're going to give it a bigger question where answer is longer so that we get to see how streaming works. And in this case, since this is a step-by-step method, so what's going to happen is we're going to have to create a loop around it. Chunk in response. So as long as the little chunks that keep coming, we will be printing them chunk.content, and which ends in space and flush equals true. And this is because normally the print method buffers the answers and then prints. By using flush.true, we're telling print that as soon as this content is available, just print it. So now let's go and run it and see what happens, how the answers show up. See, step by step in a stream it shows up, and that's the difference between stream and invoke. And before we move to Anthropic, let's compare this timing, GPT-4o's timing, with the other guys, right? So let's see. All right, pretty much instantaneous. So now let's disable this and get O1 mini going. Now let's see how long it takes. All right, so it looks like it's pretty much the same speed as 4.0. Now let's see how the actual O1 does. Now it's taking a little bit longer, as you can see. And finally, the result shows up. So pretty much we can say that GPT-4o and O1 mini, the speed wise, they're pretty much the same, but O1 preview or actual O1 model takes a bit of time. And one thing you should know from here is that O1 mini and O1 preview are not ready to accept system prompts. What is system prompt? I will show them in this video a little bit later. Now let's get started with Anthropic. All right, so this is Anthropic. So we're bringing in chat Anthropic from LangChain Anthropic, and then we are creating our runnable sequence or the model like this, and these are the arguments. Now, these similar arguments can be used for OpenAI also. I just kept it simple. As we progress along, I'm going to be adding new stuff so that we can learn in progression. All right, so in here, the model is Claude 3.5 Sonnet, temperature 0, max token 1024, timeout none, max retries 2. Now, these are optional. If we don't use them, the default is used. So I'm just putting it out there just so you know. So now that our model or the runnable sequence is made, now we are sending a prompt, who is Donald Trump, in one sentence, and then we use that prompt to invoke this Claude model or our runnable sequence to see the answer. So let's hit it. Boom, there you go. This is the answer. And let's check Langsmith. Here you go, the Anthropic. This is the one we just used. All right, let's go back. Now let's get started with Groq or Llama 3.2. All right, so this is the Groq service implementation so that we can get the open source models like Llama 3.2 90 billion. And just like before, you can see that we are just using the chat Groq method and sending all these arguments just like before to create our runnable sequence. But the rest, we are doing it a little bit differently. This time we're bringing in human message and system message from LangChain schema to organize our messages a little bit. Before we just worked with human message, right? Asking questions, getting answered, that's it. But this time we're going to add a system message. And this is where our basic prompt engineering can begin. And this is where, by using system message, we can actually change the character and attitude of the entire model's response. We can give it direction to follow. We'll get a little bit deeper into it a little bit later. But right now, let's read what the system message here is. You are a helpful AI assistant. When you introduce yourself, let the user know what LLM you are based on. Simple. I mean, besides normal answer, we're just gonna expect an answer saying which model this is based on, and then the human message, who is Sam Harris, in one sentence. This is pretty much the prompt that we were using before. Combining those, we create a message array. Then the rest is simple. Response equals Groq model invoke. This time, instead of prompt, we're sending the whole message, and we're using pprint to print out response.content. So let's run it. All right, so now look at the answer. I am an AI assistant based on Llama, large language model application, blah, blah, blah. So it's pretty much telling us that it's one of the Llama models. And then in the second line, it answered who Sam Harris is. So you can already see that the prompt engineering in action, right? So let's go do the same with Google Gemini Pro. Okay, so this time we're bringing in Chat Google Generative AI. That's the method from Google Gen AI. And with this variable, Google model, by invoking this function, we are creating a runnable sequence with our model. And one extra line you can see here, I intentionally kept it, is because in case you are actually coding it locally, and you have a .env file and you want to load it up, and this is the way to do it. Inside that method, you can actually send this argument. And right now, this is actually not necessary because we've already defined it above, so it's not going to be necessary. Just like before, from schema, we're bringing in human message, system message. And this is also AI message. This is also another one. Can be used for advanced prompt engineering, but at this point, we're not going to need it. I'm just showing it that it is available for you to use. And the rest is exactly the same. In here, I'm actually giving it the same instruction just to let us know which model it is based on, and via the system message. And then the human message is who is Elon Musk in one sentence. And as usual with the Google model, this is the runnable sequence we built, and we're passing the messages here to invoke it. And then we just print it out. So let's do that. All right, so Gemini sometimes it acts crazy a little bit. See, now right now it's just saying large language model. So let's try again. Sometimes it actually give you that it actually based on a Gemini. Once again, let me see. No, it's not doing it. I mean, by the way, it actually sometimes tells you that it's Gemini, but it's not doing it. And one thing you should know that Gemini Pro is the worst model of all the models in the world. I mean, this is the worst. I mean, it is so full of hallucination that it's unbelievable. I mean, right here, it's not telling you what model. I mean, that's just crazy. Anyway, we finally get the answer. So now let's dig a little bit deeper into the prompt engineering. All right, so we're going to use the Groq model, which is the Llama 3.2. And here you can see I kept everything the same, but just disabled the previous system message, replaced it with you are an elementary school teacher, answer questions accordingly, right? And for the human message, I'm just asking it, tell me about the planet Earth in 3 sentences. Now remember, this time we're giving it the personality of a elementary school teacher. So let's kick it off. All right, look at that. See, at the very beginning it says, kids, let's talk about amazing planet blah blah blah. So it's nice and breezy, as if it is talking to kids and keeping it very, very simple, right? Now next we're going to change it a little bit, show you what can be done with prompt engineering. All right, so once again, as you can see, this is the previous answer and we kept everything the same. The Groq model, only thing we're changing here is now we're giving it a personality, saying you are a PhD level university teacher, answer questions accordingly. But we're going to keep the question exactly the same. Tell me about the planet Earth in 3 sentences. So, and as you can see, this was your previous answer. And let's run it. Boom, there you go. Look at the answer now. Planet Earth, our home, blah, 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 71% water, 29% land, blah, 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 blah. Approximately 4.54 billion years ago it started, blah, 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 you know. So as you can see, just by changing the system message, we change the entire personality of this model, and thus the answer is completely different. Exact same question, completely different answer. So this could be the 101 for prompt engineering for you. And with this, I conclude this video. Please like and subscribe. And until next time, thanks for watching.